In this video, we're going to be looking at topic 4D, the alkenes, and we're going to be focusing on the single science outcomes for IGCSE chemistry from Edexcel. So similar to the alkanes, we're going to look at the functional group, we're going to look at the general formula, we're going to be looking at this time why we classify them as unsaturated hydrocarbons, and looking at the structures, and then how we can use the bromine water test in order to distinguish between an alkane and an alkene. So alkenes are another homologous series. Just a reminder, remember a homologous series is this family of compounds, and it means that they have similar chemical and physical properties, and they're also going to share a general formula. So they are this family, and this time they contain this functional group of a carbon-to-carbon double bond. So the alkenes are slightly different to the alkanes. This time they have this multiple double bond. And we call them unsaturated hydrocarbons. Now again, this could be a very common exam question, very similar to the alkanes. So why do we call it a hydrocarbon? Well, it's because we have hydrogen and carbon only. And why are they unsaturated? Well, it's because they contain at least one double bond between the carbons. That is what we call unsaturation, where there is a multiple bond, and in this case, it's a double bond between the two carbons. Now, the general formula for the alkenes is nice and simple. It is CnH2n, basically meaning you take the number of carbons and you double it and you get the number of hydrogens. For example, if n was equal to 20, I would have C20H, and it would be 20 times 2. So I would have a formula of C20H40. Now you only need to know the formulae and structures for the first 4 members of the alkenes, and we're going to look at them now. So the first member of the alkenes is going to be ethene. Now remember, we said for the alkanes, this ending, I think like the surname, so this ene is the surname or the family name for the alkenes. So if it ends in ene, it belongs to this family of compounds. And eth means 2. So we're going to have our molecular, our structural, and of course our displayed formulas. So if I have 2 carbons, my general formula tells me if I double it, I will get my hydrogen, so I have C2H4. So for my displayed, I have my 2 carbons, and they're the only 2 carbons that could possibly have the double bond. So I draw my double bond in like that, and then I fill in hydrogens to make sure that each carbon has 4 possible bonds. And I can break that down to CH2, and this time I show the double bond, so I physically draw the double bond into my structural formula to show where it is. For the second one, we have propene, prop meaning 3, so I have C3H6. So for my displayed, I'm going to draw my 3 carbons. Now it doesn't matter where you put the double bond, this is going to be the same molecule regardless of where you put it, so I'm going to put it at the start. And then this is a single bond, so your alkene should only ever have 1 double bond. And then again, I fill my hydrogens so that every single carbon has 4 bonds. So I need 2 on the first one, I only need 1 on the second, and then I need 3 hydrogens on the third. And again, for my structural, I break it down and I show my double bond. So I have CH2, the double bond, CH, and then CH3. And then lastly, I can have butene. Again, ene telling me it's an alkene, and the but tells me I have C4. So I double that and I get 8 hydrogens. So I can have 1, 2, 3, 4 carbons. Now the double bond here does matter where you put it, so I'm going to come back to that in just a minute and explain that in more detail. For now, I'm just going to put it between the first 2 carbons, and then all my others are going to be single bonds. I fill in my hydrogens, making sure that every single carbon only has 4 bonds. So you will always end up with a space down below or at the top, depending on where you put your carbons, where you put your hydrogens. Not every carbon is going to be surrounded by hydrogens the way they are in the alkanes. And again, you have your CH2, your double bond, a CH, a CH2, and a CH3 for your structural. So those are the three members that you have to know. You can see there they're drawn out a little bit clearer than what I had. So we've got our name, molecular formula, structural, and displayed formula. You do not need to know the empirical formula, so don't worry about that. Now, we mentioned isomers when we talked about the alkanes, and we said this is when we have the same molecular formula, but we have a different structure. And the one thing that I want to point out for the alkenes, and one thing that you are going to be asked about in single science, is the position of the double bond. So we can add branches and make the chain shorter, but you're not going to be examined on that. What you would be examined on is where the double bond is. So if we go back to our example of butene, so this is our 4 carbons, we can actually have the double bond in 2 different places. So let's split this down the centre and we'll look at the 2 possibilities. So we've got our 4 carbons on both sides. Okay, and I'm going to number them 1, 2, 3, and 4, just to make it a bit easier when we're explaining. So your double bond can either go between carbon number 1 and carbon number 2, or carbon number 2 and carbon number 3. Now, when we number the carbons the way that I have there, we always number them so that the double bond is on the lowest possible number. Meaning, if I had my carbons again, if I draw it just up here, and I put my double bond there, I would actually number them this time from right to left. So you can never have your double bond between carbons 3 and 4. They can only ever be between 1 and 2 or 2 and 3. So I'm going to fill in the rest of my structure, showing all my hydrogens and the rest of my single bonds. And do the same on the second one, making sure that you have no more than 4 bonds to each of the carbons. Now, what we need to understand is that, yes, both of these molecules are butene, but they are actually 2 different substances, so we can't call them the same thing. Imagine they are just like siblings in a family. So we know that they belong to the same family because they have the same surname, they have this ENE, but they're not exactly the same thing. It's like they're twins. You don't call twins the same name. So what we do is we specify where the double bond is, and this tells us that they are 2 different substances. And what we do is we write the number in the centre, and we pick the lower of the 2 numbers. So if the carbon is between 1 and 2, we pick the 1, and this now becomes but1ene, telling me that my double bond is between carbons 1 and 2. And this one then becomes but2ene, telling me that my double bond is between carbons 2 and 3. And we can show that in our structural formulas and our displayed formulas, and we can even have our we can also look at the trends and the physical properties of the alkenes, and these are actually the same trends that we see in the alkanes. So there is quite a lot of similarities here. So as we increase our number of carbons, we're going to increase our boiling point. And that's exactly the same as we've seen for the alkanes. So up to C4H8, they are gases. Up to C16H32, they are liquids. And above this, then they're going to be solids. Now, the main difference between the alkanes and the alkenes is when we look at the chemical reactions. And this is because we have this double bond. This carbon-to-carbon double bond actually makes the alkenes quite reactive. So the opposite of our alkanes, where they were quite unreactive, this carbon-to-carbon double bond still allows it to react. Now, one reaction that is exactly the same, no difference, is our combustion. So regardless of if we have complete or incomplete combustion, we're still going to produce these same products. So if we have the complete combustion of ethene, we have C2H4, which is a gas, reacting with the oxygen to form our same products that we've seen a few times now, the carbon dioxide and the water. And of course, we always want to balance it, so we need a 2 in front of the carbons, a 2 in front of the hydrogens, and that then gives me 6 oxygens, so I need a 3 as my coefficient there. So remember, make sure to practice writing out your balanced chemical equations for these combustion reactions. Despite the fact that they can be burned, alkenes actually tend not to be burned because they are much more useful in other chemical reactions. And the 2 chemical reactions that you will learn is addition, which we're just about to cover, and polymerization. And polymerization will be covered in topic 4H when we talk about polymers. So alkenes can be burned, but we tend to use them for other things. Usually if we're going to burn a hydrocarbon, it will be an alkane. Now, alkanes and alkenes are both colourless liquids, meaning they look just like water. So if we want to tell them apart, if they were in unlabelled bottles, we have to carry out specific chemical tests in order to do this. Now, you learned about chemical tests back in topic 2H, where you looked at cations, anions, and gases, and being able to tell them apart with chemical tests. This is just another way that we use this chemical test, only this time we're focusing on organic chemistry. And the way that we do this is we take the reaction of bromine water with the carbon-to-carbon bond, and it takes advantage of a type of reaction known as an addition reaction. Now, in single science, you're not going to be asked too much about this, but I do think it's important that you have at least a bit of a background knowledge. So this is just for your own knowledge. You're not going to be asked this. But an addition reaction is when we break the carbon-to-carbon double bond and we form a carbon-to-carbon single bond. So we're removing one of those bonds. That now means that there is space in the carbon to react and add something else, and we add new atoms. And this forms then a saturated product, meaning our product no longer has a double bond. So this reaction with the bromine water is testing for unsaturation. So we are testing to see, is there a double bond present in the structure? So the alkenes will react with this bromine water because they're unsaturated, as we've said, and the bromine water is going to add across the carbon-to-carbon bond. Alkanes do not have this double bond, so they are not going to undergo this reaction. When we get the water being added to the alkenes, it will decolorize. And this is a very, very key word. I want you to make sure that this is memorized. When we're talking about decolorization, it means it loses the colour. And it loses the colour because it's undergoing a chemical reaction. And this will only be seen with the alkenes. You will not get a decolorization with the alkanes, meaning you can then tell them apart. So you would get something like this. The bromine water, or the bromine, is a kind of orange-brown colour. And when you add it into an alkane, you see no change. It stays this orange-brown colour, so we get no decolorization. When you add it into an alkene, it will react with the bromine water, so we get this addition reaction, and it causes the bromine water to decolorize, meaning we form a colourless solution. So this is how we test for unsaturation. We will have decolorization of bromine water. Make sure that if you're saying that you see a colour change, you're specifying it's going from orange-brown to colourless. Remember, not clear. Clear, it doesn't mean colourless. There are two different words. So let's finish off by looking at some past paper questions. So heptane belongs to a homologous series of compounds called the alkanes. And the general formula for the alkanes is CnH2n plus 2. Heptene belongs to a homologous series called the alkenes. give the general formula for the alkenes. Okay, so we're just looking for the general formula. We're not worried about the heptene just now. We'll come back to that. So our alkenes is CnH2n. Nice, easy question. Now we want to complete the following diagram to show the structural formula for the heptene by inserting the lines to show the covalent bonds. Now what you will notice, we need to now count how many hydrogens we have. We cannot add any hydrogens. All we can do is add the covalent bonds between the carbon atoms. So if we look at the carbon on the end, which on this side, you can see that it only has 2 hydrogens. And we know that carbon has to have 4 bonds, which means I must have my double bond here, because I cannot add on another hydrogen. If I was to put a single bond there, my carbon would be missing 1 bond. If I've already added my double bond, then all the others have to be single. So I just draw nice single lines, and I can go through each carbon and check that it only bonds to 4 other substances. So we get 4 bonds being formed for every carbon, and that's our 2 marks. Now, when heptene is added to bromine water and the mixture is shaken, a reaction occurs. We want to state the type of reaction, give the colour of the bromine water before and after. So the type of reaction, this is an addition reaction. The colour before, we're going to say is orange. Okay, you can say a kind of a yellow or a brown would also be accepted, but we'll stick with orange. That's mostly the colour that's in the mark schemes. And then the colour after is colourless. Remember, not clear, not transparent, nothing like that. We're talking about colourless. That is the only answer that will be accepted. And then part 4, explain in terms of the bond present why heptane is saturated and heptene is unsaturated. So the heptane has all single carbon-to-carbon bonds. Okay, remember we're having to specify that it's the carbon-to-carbon bonds, whereas heptene, because it is unsaturated, contains at least 1 carbon-to-carbon double bond. So the saturated, or the heptane, all carbon-to-carbon single bonds. The heptene has at least 1 carbon-to-carbon double bond. And there you can see the mark scheme for those questions, being very specific about the colours. So really focus on this answer here, that we will not accept red or any other combination, and we'll have nothing apart from colourless as the answer for the after the bromine water has been added. So that's everything for topic 4D, the alkenes for single science. Again, I would strongly suggest that you practice drawing out the structures, including when we've got but1-ene and but2-ene, remembering that double bond can move, and also practice drawing out and writing the chemical equations for the combustion reactions. If you do have any questions, feel free to leave a comment below, and we hope to see you back soon.